This one, as I promised, is on that small battery, the smallest one. This is the leaf carbon. Leaf mixed with sugar, as I said. You would have seen the charged state litmus test. That is under discharge conditions, as in just before this finished it was about 0.8 of a volt, and that is the discharge state pH values for anode and cathode. Okay, so let me just have a look at that. They are both sitting at around I'd say a comfortable 9, with one being just ever so slightly darker than the other. So anode and cathode, there we go. And we've got some recovery. I think this is its 4th charge or something like that. I'm just going to put it back on charge. We've got those pesky lines again, so I'll make this quick. 20 milliwatt hours, 15 milliamp hours was the both capacities. So like I say, I'm going to charge that again now. We've got a nice battery curve, that's good. Anode is, as I said, activated carbon, and cathode is leaf carbon with sugar and a little bit of sulfur. Now what I'm going to do, like I say, I'm going to charge this again, be its 4th charge, and then we'll move on to we'll have a look at it again and move on to the paper battery side of it. Electrolyte was partly aqueous, and I say partly because there is some ethylene glycol in there. And urea. That's it. That's all there is to it. Okay, I think this is the 5th charge now. We're still set at, as you will see, 100 milliamps, and there it is, top right, 100 milliamp constant current load. Don't remember how long it lasted for last time, actually. I should have checked, but I didn't. So this is the 2nd run on the leaf carbon with sugar. Let's see how it does. Now then, that was charge number 6, 7 minutes 48, not far off 8 minutes. I've just put it back on charge. There was a good recovery. I should have really shown that as well, but I forgot. 18 milliwatt hours, 13 milliamp hours capacity. Lovely curve, heading in the right direction. 100 milliamps, constant current load, again, on that small battery there. And the surface area is 4 centimeters by 4 centimeters. Quite unbelievable, really. 100 milliamps from that, you know, almost 8 minutes. And again, this is still the leaf carbon, leaf and sugar carbon, with some sulfur. So I'm charging it again, and what I'm going to do now is I'm going to change that to 150 milliamps for this run. Now you would expect to maybe get a third of that, almost 8 minutes or something like that. What we'll actually get, I don't know, but you know what, that tiny battery there, I'm going to try it. Now you can see the curve there, That's not a bad curve, that. No glitch at 0.5. So I'll be back. Okay, so this has been on charge for a little while. I don't know, about 10-15 minutes or something. I don't really know. I'll clear that curve. And as a recap, we've got 7:48, almost 8 minutes. Don't really care about the energy or capacity at this stage on this small battery, because it's, well, really small, isn't it? But the main thing is 150 milliamps. So as a constant current load, I'm going to turn off the charger. Got about the same voltage, 2.5. Not real voltage, obviously, it's 2.2, isn't it? So I'm going to press start at that. Now we got quite a volt drop, which you would expect, because it really is a tiny surface area, this one. So let's let that go and see where we get with it. 150 milliamps, constant current load. I'll be back. Okay, so down to 0.5 volts. Still 150 milliamps, constant current load. 4.5 minutes. Nice curve. So we got past that 0.5 again without that, well, a little bit of a glitch. And there we go, all stop. 4.25 minutes, 150 milliamps from that tiny battery. Wow, that's unreal. For my own purposes, I'm going to charge it again and run it at 200 milliamps. I may or may not show that, I don't know. Okay, just to recap then, 4 minutes 45, 150 milliamps, only 13 milliwatt hours, and 12 milliamp hours capacity. I'm going to turn this off and press start. Now, what you see is what I expected, a massive volt drop. And the reason for that is that 200 milliamps, constant current load. Now that's kind of a messy old line there to start with, but you know, it is what it is. I think because this is going to be over quickly, I'll leave the camera on and see how this thing does. 200 milliamps on that tiny battery. Now before this thing shuts off, if anyone's in any doubt, that's the one that's connected, that's the one that's running. Got that bit of a glitch again at 0.5, but hey ho, all about to stop. Wow, nearly 3 minutes. 200 milliamps. Unbelievable. Okay, this is the second test piece, which is the paper battery. The actual surface area on there is nowhere near as big as you can see. It's actually quite a lot smaller than what you can see there. That plate is quite big. But anyway, it's on the data logger, and there it is. As you can see, it's a 50 milliamp constant current load. We are 1 minute, well 2 minutes in, and dare I say it, it's looking quite good at the moment, you know, for that bit of paper. So I can give you some idea of the size of that surface area. Right, that surface area is 60 millimeters by 70 millimeters, so 6 centimeters by 7 on a piece of paper. And as you saw, it's all hooked up. That's the one that's running. 3 minutes 22 in, 1.9 volts left. Now I'm guessing what I could do is leave this running and speed the whole thing up at the end of it so you can see the full test. That's how I'd like to do it. I think we're going to get a half decent curve out of this. I like the way it started off. That wasn't that straight line that dropped. It was a nice curve into it, so it showed me straight away that it got a little bit of power behind it. I'll charge that at 3.3 volts. Okay then, almost 15 minutes. I am thoroughly impressed with that for a 50 milliamp load. We've got some recovery as well. That's always a bonus. 18 milliwatt hours, 12 milliamp hour capacity according to that. That ain't bad for a bit of paper, especially with the size of the surface area on there. So yeah, I think what I'll do is I'll put that back on charge at 3.3 volts. We're drawing 1.6 amps at the moment, dropping quite quickly, as you can see. That's the charge current at the bottom there. 3.3 volts, we're up to 3.22 there, and this thing updates slower than the actual meters obviously, so almost 3.2 and 3.2 on the meter, and it's still that battery there. Look, that's it. That's the one that's just run. That's the one that's hooked up. The larger one there is in bits, and the other one there, well, that's just nothing, is it? You know. So there we go. The next run I won't do the whole thing. I should just do segments of it, so it doesn't get too boring. I'll pause the video and come back. Right, this battery, I've just taken a swab. That's the cathode and that's the anode, and we've got, I think, a 9 there. This is in charge mode, don't forget, and a 2 there, or somewhere in between those two, 1 and 2, but I'd go for 2 myself, and I think I'd go for possibly in between 9 and 10, but I'd err more on the 9 side than anything else. So yeah, there it is. That's 10 minutes into the charge, so we're at a fairly acidic 2 on the cathode, and starting to border towards alkaline on the anode. So there we go. This thing's still drawing 500 milliamps according to that. That's this thing here, this paper battery. Excuse me, paper battery. That was the last curve. 15 minutes or 7 seconds. So I'm just going to give this another, I don't know, maybe 5 minutes or something like that, and go again. I'll be back. Right, well, I'm growing impatient, so that was the old curve, as we know. 15 minutes bar 7 seconds. We will clear that curve, turn off the charger and press start. So, not a bad start. Let's see what this run produces. I'll probably come back at a volt or something like that. Maybe just before, I don't know yet, we'll see. If you've got a keen eye, you'll notice that this is not 50 milliamps, it's 70. I was going to do 100, but I thought it might be a little bit too much for that paper battery. But I might try that next. But I'll see how this one goes first, I think. Catch you in a minute. Holding 2.2 volts there, that's pretty good for 70 milliamps. A little paper battery. Right, I've come back in at 1.3 volts actually. 6.5 minutes so far. Nice looking curve. Can't complain about that. 15 milliwatt hours so far, and 8 milliamperes as a capacity. So at the moment it would only do 8 milliamps for an hour. What I should do actually is one of the days is look at that capacity, and whatever it says, set this thing up at exactly that capacity and run it and see if it will do the hour. I suppose we'd know whether it was telling the truth then. But anyways, that's where we are at the moment. We're at 1.2 volts there now, as you can see. 70 milliamps constant current load. I'll be back. Okay, I was doing other things and missed the end of this, but we got a nice recovery again, up to 1 volt already. 10 minutes 20 there, look, at 70 milliamps. 12 milliamperes capacity, 19 milliwatt hours as well. So back on charge then. I think what I'm going to do this time is I'm going to change that to 100 milliamps and see how we get on. I'll come back. This is still the paper battery, don't forget. Okay then, that was the last curve, which we will clear. We can see from the data that we've got 10 minutes 20, and I'm going to start, well, turn the charge off first and press start. Now that's a pretty good start. Quite pleased with that, especially when you look at that. I've reset it to 100 milliamps, and yep, we are still on that paper battery there. Okay, so I'll do my best to come back. I'm tidying up at the moment, but doesn't really matter with these things because it tells you the whole story at the end of it. It's not like running the motors with a timer, you know, the little clocks. It's all on screen, all the data, so this is pretty good. I'll come back. Okay, I did miss it again, but it doesn't matter because we've got recovery up to 1.2 volts. 7 minutes at 100 milliamps for that little paper battery. Whew. Bit of an all over the place curve this time. It sort of dipped out a little bit there and then a little bit at the end, but overall quite interesting. And I also did a couple of dips, one charge, one discharge. Now on that discharge it got a bit lighter, didn't it? And on the cathode side didn't really change the pH on there, but the anode sort of went towards neutral a bit more. You probably can't really see that, but I can in this other light. But it was, yeah, it was fairly light, so it kind of went to a 7 really, pH of 7. So that's that. The next one I'm going to set up is the larger one, which is 7 centimeters by 14, with the same carbons on, same electrolyte, same binder, same everything, just a larger surface area. I'll be back. Actually, I'm back, and the reason for that is I always kind of like to show you what's going on if I can, and this one is no exception. Take that massive plate off there and then you can see the actual, you know, surface area of the paper battery. Now obviously that's carbon fibre weave, and whatever that is what the surface area is. So we're looking at that there. That's the surface area. If I can just peel that off, so there's the carbon fibre weave, and there is the bit of paper with the anode material, which has flaked off a bit there, stuck onto the plate, and the cathode material there. So as flimsy as it is, there it is, the paper battery. So just wanted to show you that bit. Speak to you soon. So there's the paper battery, and there's the surface area. That's the piece of paper I've just shown you. Okay, that's it. It can't be any bigger. That's impossible, you know. So that's that. Now here is the last run that I did. Now I haven't perfected things yet. This is all fresh, new, and all the rest of it. And that was the curve. Okay, I'm going to explain a bit about this curve in a minute. But like I said, there it is, 200 milliamps, 8 minutes. Okay, now this is on charge at the moment, so what I'm going to do is knock the charger off. I'm going to clear that curve like so. Now the voltage is fairly high, but this really is it always kind of settles to about 2.2, 2.3 volts. You know, it's not a 2.5 volt cell by any means, but that's set at 200 milliamps there, and there it is. Well, you'll see it in a second. I'm going to start this off now like that, and you will see 200 milliamps there. Okay, now there's a bit of a volt drop. We can see that, we know that. This thing's probably a bit dry. I should have put some electrolyte in there, but I didn't. But I just wanted to show you this thing, this little paper battery there at 200 milliamps. Now that's quite a flat line there, isn't it? You know, that is pretty good, really. By now, 30 seconds, if I'd have put some electrolyte in there, or even perhaps charged this for a little bit longer, what you would have seen by now, it would still be saying well over 2 volts. I mean, even 45 seconds in, well over 2 volts. So really I've done it the wrong way around again, but it doesn't matter, you know. That will be shown, and that's all there is to it. So I'm just going to let that run and I'll come back. Okay, I've come in at just about 0.6 volts there. Now obviously this run isn't going to be any good, or sorry, not as good as the last one, but I don't care about that. It's just a quick demonstration. It's still that small paper battery that you saw. It's still doing 200 milliamps constant current loading, and we've got 6.5 minutes at the moment, so that's that. I've just checked the pH again while this was discharging, and the anode seems to not have changed a lot, but the cathode has. And the cathode, okay, that's just stopped. Look, almost 7 minutes, so that's that. I'm going to move the camera back now. I'll pause it first. Well, actually I'll unpause it because I just wanted to show you that that is the battery that's on, you know, that you've just seen on the data logger. That's the one that's hooked up there to the dummy load, and that's that. So I'm going to pause this and stick it back up on my tripod. Right, I was that involved in what I was doing I forgot to put the camera on, well, on record. As you can see, there's a 250 milliamp constant current load, top right hand corner. We're down to 0.9, well, almost a volt, and we've been going for 4 minutes and 32. So this is a 250 milliamp load run that I said I was going to do. But there's a difference. I started out, I thought, right, I'm going to build a new battery. I'm not just going to freshen up the electrolyte. I'm going to build a new battery because I wanted to excuse me, I wanted to put the graphite on the carbon fibre weave in a different way, i.e. a really thin coating, just paint it on. It was almost like an ink that I'd painted on, really, and that's what I did. But then I thought, hold on a minute, I haven't tried this yet, which is another material for the cathode. It's been sat around now for quite a while. Keep meaning to try it, and I'm trying it now. And it works. So what I'm going to do is a couple of runs with this. I'm going to do a 250, which I'm doing. I shall do a 200 after this. Now we're down to 0.8 there. This is its second run, second charge. And we got 6 minutes, look. That's not bad, is it? The first run on the first charge was 200 milliamps, and it was about 15 minutes, I think it was, something like that. So looking pretty good. And yeah, I can't wait to show you this material. Now the curve is starting to ebb towards a capacitor curve there. It's dipping just ever so slightly, and it's what I've found with these whatever I've done with this setup, with this this graphite now on the anode, painted it on the carbon fibre weave. I found that the first curve is almost a capacitor curve, and when you get to about the fourth charge, it's almost like you've got to condition the battery, and then it turns into a battery curve. So this is what I was talking about earlier when I said I'll talk about that curve, because it was like half and half, wasn't it? You know. But anyway, I might as well see this one through, put it back on charge, and then do another run. But I'll do 200 milliamps. Obviously, this is really pushing the boat out for this, and I'll move this now before that stops. And it is still that small paper battery, and you can see the paper there. If I can just hold this with one hand, there's the paper. Okay, there it is, there. I mean, take no notice about, you know, the size of that plate on top. It's just a pressure plate. There's the carbon fibre weave, look, on the anode, and you can see the graphite there that I've painted on. There's the graphite, there it is, look. The binder isn't very strong according to that, but you know, it's graphite, it's a funny material. So there we have it then. We're on 8 minutes at 250 milliamps. Now I started this whole thing off with an 8-minute run, didn't I, at 200 milliamps with the old battery. Then I did another run. Oh, we've got that glitch again, look, at 0.5, well, 0.65 of a volt this time. There you go. Oh, double glitch. Lovely. Okay, whatever. Cut-off is still 0.4, obviously, but it's continuing, so we're okay. So now, at 250 milliamps, on the same battery, same setup, same size, same surface area size, we've got 9 minutes, look, at 250 milliamps, constant current load. I'm over the moon about that, especially as I've got this new material, not carbon fibre weave, on the cathode. Now this is the first test with this new material, so didn't really know what to expect, to be honest, and still don't, although I'd love that to go to 10 minutes, but it's not going to, is it? It's you know, no. There you go, 9 minutes 44, look, not bad. So I'm going to put that back on charge. Right, I'm growing impatient. I've turned the volts up to 4.8 volts. Interestingly enough, that's, as you can see, on charge, 4.712. Like I say, I'm getting impatient. There's the battery, and I think you can see that there is no outgassing at all, I'm glad to say. And it is that same electrolyte, 25% H2O. So the last run was 9:44. That was at 250 milliamps, and this is a brand new battery, don't forget. We're on the third charge now, so what I'm going to do is turn off the charger, let the voltage settle, and give it a run at 200 milliamps with this new material on the cathode. Not active material, but right, so I'm just waiting for that to settle down a bit, as in the electrode. Now the resistance of this new material isn't fantastic, so overall that could be detrimental, but I've got something up my sleeve for that as well. So right, 2.4, that will do. Let's press start at 200 milliamps. Now I don't think I charged it for long enough, but it doesn't really matter at the moment. I'm just testing this material, looking at the curves and all the rest of it. And of course this I shouldn't really do this. I've mixed and matched again. I've painted the graphite on the carbon fibre weave for the anode a lot thinner this time, so whether that's going to be detrimental, I don't know. But of course I've mixed that with this new material as well, which you shouldn't do. But that's just me all over, Mr. Impatient again. Anyway, I'm going to let that run. I've got a couple of things to do. I'll just come back at the end because it's a data logger, isn't it? I don't need to stand around watching it. I actually don't think this is going to do as well as the 250, but there you go. I'll be back. Right, I've come in at 0.7, as you can see, on this 200 milliamp run. We're almost on 8 minutes. I'm just looking at this curve, to be honest, and it's swung back to a capacitor type curve. Not bothered about that right this minute. I think I know how to change that, to be honest. And that's all to do with the blend on the carbons that's on this cathode. And I can safely say that because I've been there many times before. So that might be the next step. But I'm just going to do another run after this. Oh, and a short circuit, because I keep forgetting the old short circuit, don't I? And I shouldn't really, but I do. Perhaps I should put a post-it note up or something like that. Kev, don't forget the short circuit. So anyway, we're up to 9 minutes again. That's okay. And there you go, 11 minutes. Yeah, don't quite know what to make of this just yet, but like I've said, it's this new material. And we got some bounce back, look, you know. Not much in the way of capacity, but then again, it was 200 milliamps. So before I forget, I'm going to change that to 100. Well, actually no, I'll go down. I'll do 150 this time. Put it back on charge, 4.8 volts, and I'll be back. Right, I've just put that back on charge. It's probably been on charge for about 30-40 seconds. And what I'm going to do is put that meter there. Now that's on the 10 amp scale. And what I'm going to do, and you'll see me do this because you'll see that voltage drop to whatever the battery voltage is now, and I'm going to do a quick short circuit and see where we are with it. Okay, so it's probably been on charge for a minute or so now. So that's that. That's the voltage, and there's the short circuit, and it did say 1.1 amps. Yeah, okay. That's generally what I expect from this one. Obviously, fully charged, you're going to get a bit more than that, but I'll be back. Right, just set this thing up for a 150 milliamp run. Turn off the charger as normal. Let that voltage settle down a little bit. Now, yeah, we'll start it at that. The last invalid value. What have I done there then? I'll be back. Right, forgot to start the camera off again. 150 milliamps. As you can see, been going for 20 seconds. 2 volts. Bit of a drop there. Big drop there. Just there. Okay. Last test on this new material. Oh, we got those pesky lines again. Oh, wow. What is going on now? Okay, we've got it all going on. What I'm going to do is put that back on charge and start again, because I'm not happy with any of this. So I'll come back. Right, I've just reset this. The run you see there on the screen, albeit well, don't quite know what happened there, was 150 milliamps. I'm charging again, 4.4 volts. I've reset it now to 100 milliamps. Now that was 19 minutes 34. That's still with this new cathode material as the electrode, not the active surface area. That's still manganese dioxide. 55 milliwatt hours, that's okay, 49 milliamp hours. So what I'm going to do is clear that. This is the following morning, so I don't know if this is if it's dried out or not, but I'm going to give it a go anyway. So let's not talk about it, let's just do it. I was waiting for the voltage to drop a little bit, but it seems to want to hang in there this time. Okay, now we've got some movement. Oh, let's just press start. We know what the voltage drop at the beginning is all about, don't we? Okay, fairly flat line, that's what we like to see. Not a major drop there. Still at 2.2. And I think I've always called this setup a 2.2 volt cell or battery or device, with the current chemistry, of course. So I'll be back. Okay, so we are 5 minutes in. Look, 1.8 volts almost, 100 milliamps. This little thing is it seems to be forming itself now, and we seem to be getting there. I don't know why this setup has to form, and I say that because when you start these things off at first, you get a definite capacitor curve and then it evolves into a battery curve. And of course some of the curves have been half battery, what I would call half battery, half capacitor, but I've seen a lot of that before in previous work. But we're on 100 milliamps now, constant current load, and it seems to be holding its own without any problems so far. Let's come back in a bit. Well, I've been out, I've been away, went to the shops and come back, and this is still running. 32 minutes then so far, 0.8 left, 100 milliamps, pretty good. We've got 53 milliamp hour capacity at the moment and 74 milliwatt hours on the energy. That's looking not too bad. Again, got this strange line, but I'm guessing that's more to do with the this new cathode material that I've got there as the electrode, so or the collector plate. Yeah, let's just let it run, eh? This is that again, that paper battery there, look. I've got this up in the air because of creepage of the electrolyte, so that's what it's all about then. Anyway, I'll come back. Well, there you have it then. 81 milliwatt hours, 64 milliamp hours, and 38 minutes. Quite impressed actually with that. At 100 milliamps. Quite impressed with that little paper battery there. And once more, there it is. Okay, I'm going to charge this up again. Okay, so that was the last run then. We'll clear that curve. That was the 100 milliamp test run. 38 minutes. What I'm going to do this time, and I'm going to make this the final one for this particular material, obviously further testing to come, but I'm going to run this at 80 milliamps. It's not fully charged, but I don't really care. It would be good, of course, if we stop that now, clear that curve again. That'll turn the charger off first. Otherwise we're going to get a fantastic run, aren't we? So I'm going to press that now. The usual volt drop there at the beginning. This time we've dropped to 2.3 volts. Okay, down to 2.2. Have to forgive any noise in the background, as there are builders around today, and also my microwave is on the go. I've got something new in there, and I hope to show that in this video, along with other stuff of course. So anyway, I'm going to let that run and I'll be back. Well, here we are. I've been away conducting an experiment which was a bit more al fresco. We've got, well, a pretty unimpressive 54 milliamp hours and 71 milliwatt hours, but it's down to charge times. I just rush things, but I just wanted to, test this thing out again to see if we got that, and we've got it again. Don't really know what it means, but I don't care. So that's the end of that then. I'm about to explain now just what this new material is. Okay, I've just done a quick 1 minute test there, as you can see, 1 minute 12, just to try this again, and that's what I'm doing now. I know I said when I did the 80 milliamps that that would be it, but me being me, I just, well, I couldn't leave it there, could I? I couldn't leave it at, you know, 250 milliamps, could I? That just wouldn't be me. So, this tiny paper battery, yet again, as you can see, is now running at 300 milliamps. Now I know we've got a massive volt drop, and you would expect that for the surface area. That's just the way it is. And I do really wish I had the time to keep charging these things up properly, but you know, it's I don't know, I'm impatient. But anyway, 300 milliamps, we're at 1.4 volts. I'm going to let that run, and I'm going to come back. Okay, we're about to come to a stop at some stage soon. We got that major glitch again at 0.5 of a volt. Really strange that. Well, it went crazy this time, didn't it? Now I've got a feeling I know what's going on with the electrolyte at that sort of voltage. I'm going to start to look at that. But look, 300 milliamps, almost 11 minutes. Well, 10:40 at the moment. We might just do the 11 minutes on this one. Maybe not. No, it's just going to let me down again, just like that. But look at the recovery. Super recovery. Yeah. Maybe I'll leave it at that. Well, guess what? I'm back. I've just kind of rapid charged this a little bit at a higher voltage. Just hope I haven't burnt the separator paper or something like that, which is what normally happens. So that was 10 minutes 56 on the last run. At 300 milliamps, of course. This one, as you can see, goes. I've done it again. Right, well, me being me, you know, I can't leave it alone. I'm going to press start straight away and see what we get. Okay, a massive volt drop again, as normal. But if you look at that top right hand corner, we're on 400 milliamps this time for that tiny paper battery. How about that? Now, I'm not expecting miracles because I did really charge this quickly, but I just wanted to see if it would cope with the 400 milliamps, which I was kind of guessing it would. But secondly, are we going to get that same strange hump in the curve? I'm quite intrigued by that, actually. Well, we are up to a minute, so can't complain there. Not for the amount of charge that's gone into this.
Okay then, pretty mixed bag of results there on this new material, which I'm going to I'll tell you all about it in a minute and show you what it is. 400 milliamps. 400 milliamps. I mean, okay, it was only 5 minutes, but from a paper battery that size, now it is that size. You know, you've seen it on camera. It was all hooked up. It was running on the data logger, and that's it. I don't know why I keep repeating myself like that, but I don't really care if people don't believe what they can see there on, you know, on this screen. I know what the results are, and of course you can conduct your own experiments from what I've said, what I've done, if you want to. It's fairly simple. So 400 milliamps from that for 5 minutes, constant current, not the motors, constant current. I've kind of got a direction at the minute now that I'm happy to pursue, and obviously I'll tell you more about that as and when. But before I tell you about this new material, I want you to look at something else. There's a new guy in town. He subscribed to my channel a while back, and I found what he was doing very interesting. He seems to have time to do a lot of research, which he does do. The guy's called Ray. I won't give you his last name because that's not for me to do. His channel is called Biocell. Now, I did put this in that other video that I keep talking about and haven't shown you, but I wanted to show this stuff first. You know, I'm excited. Yeah, Ray at Biocell. Have a look. This was the guy that put me back onto this EZ, this exclusion zone, and this EZ water, and the fact that you can make a battery from water, because in this EZ zone it's negatively charged, and there is charge separation, and I'm going to show that and prove that at the end of this video. But I wanted to just have a little chat about this new material, didn't I? So Biocell, he's only got 3 subscribers. I don't understand. Ray, your video quality is getting better. I think you've got a problem with maybe keywords and stuff like that in your keyword search box. I don't know whether you actually use that. I didn't earlier on, and some of my older videos I've still only got 271 views. That's because I never did put keywords in, and I always only put a title. But I think a couple of things, Ray. If you were to put carbon battery in your title as well, that's a good search path for people, because a lot of people search that carbon battery, and if you're using, fair enough, if you're not using carbon, then don't do it. But if you're using your piece of graphite, do it. I mean, my keywords, I tend to put stuff like battery, rechargeable battery, carbon battery, all carbon battery, dual carbon battery, electrolyte, deep eutectic solvent, ionic liquid, ionic bonds, stuff like that. You know, just general stuff that people would search for under this, you know, this what we're doing. So yeah, Ray, Biocell, 3 subscribers. I'm quite amazed at that, really, because it is very, very interesting. If you look at it from the beginning and look at how it's evolved over, I think there's 21 videos now. They're quite short videos. They're not, you know, like mine, which are fairly long. Yeah, that's it then. So back to this all new wonder material. What is it? Well, it's been sat around for ages now, and I keep looking at it and looking at it and looking at it. Now, earlier on in this video I said, okay, I've done that. What I'm going to do now is do this, but I didn't do it, which was, I think, run it at 200 milliamps, the 200 milliamp test with this new anode setup with the carbon fibre weave with painted graphite on it. Not as the active material by any means, but I confused the battery when I put the carbon fibre weave top and bottom, you know, anode and cathode collectors, and it thought it was a capacitor and all the rest of it. So, you know, we found the missing link, which was, it was expecting graphite, wasn't it? Because it's always had graphite as a plate. So that's what I did, as I've explained. But when I come to do this new test, I thought, I looked at that material once more and I thought, do you know what? That's it, I'm going to try it. I had tried it before, I must admit, when I first got it, and I tried it on the anode and it didn't work. In fact, it was useless. This time I put it on the cathode. So there's a good tip. Why it works best on the cathode, I don't know. I don't care. What I want to do is just make it work as well as it possibly can. Now this material I saw probably about a year ago, and the builders are off again. I looked at it and I thought, you know, that looks interesting, because it's a material that was used in these big flow batteries, these redox flow batteries, where you've got these tanks of electrolytes, and I don't really understand it that much. I don't want to understand it right this minute. A flow battery. Now, I'm just going with this flow. So this material, then, it's a carbon felt, and there it is. Okay, it is conductive, but not very conductive. For instance, I've got my meter set on 200 ohms, and all I'm going to do is push the probes into it, let's say 150 millimeters apart, as you can see, and we've got 1.4 ohms. Now that's pretty good by any standards at that sort of a distance, you know. I'll tell you what I'll do. Now I can't see what you can see now. I'll do that. That's a good 200 millimeters apart, maybe 250 actually. Okay, 1.7 ohms. You know, I mean, let's try and. Yeah, no, I'm forcing the probe now. It's gone down to 1.6. I mean, that is pretty good, you know. You couldn't grumble at that, but it's not as low as we wanted it to be. Obviously, I feel that you need about 0.4, 0.3, 0.4, as I seem to get from, you know, metals with this meter, this particular meter. And I've tried it with a good meter as well. Obviously, everything I do, you know, my carbons, when I say, oh, that's 0.9 and that one's 0.8, I don't just rely on one meter. I check it on a good meter as well. Now, it's not a fluke, as in meter, but it's a good meter. And all of the meters I test with all give the same result, more or less, within a fraction. So I'm quite happy to do this, you know. Yes, I'm going to build a square tester that Robert Murray Smith showed us in one of his last videos. I'll be doing that, but it's having the time. I haven't got the time yet. But anyway, back to this. That's what it is. It's this. You couldn't call it a foam. It is a felt, and that is what is on that paper battery that you've seen. That you've just seen do even 300 milliamps, which I think is pretty phenomenal. And that's how big it is. Okay, that's the size of it. Genuinely, I've placed this over that on camera while I was going to the data logger. It can't be any bigger. But the one thing I will say, to be genuine about it, I did paint more material on the anode, the activated carbon, you know, so it's kind of twice as thick as you would expect it to be, just with one sort of coat. I did two. I did one in the other direction once the first one had dried. And as a general rule of thumb, I find that you can go 3 anode, 1 cathode if you like. You don't have to go 3 cathode as well. It doesn't work that way. But anyway, back to this. There is a problem, and this has occurred, and I don't know why, with this material. It works, as you can see. Now I tend to feel that, being a felt, that it's going to hold on to electrolyte as well. I haven't tried it on its own yet, just on its own. I've got a feeling it'll work and give a little bit, and work as possibly its own active area, a bit like carbon fibre weave does. And then when you process it in the kiln, like Robert did, you get, I think he worked it out at 20% extra. Now I haven't done any of that yet, and I don't intend to. I'm keeping that in the bank for when I get the result I'm after, and I'm going to think, now I want that 20%. So I'm saving all of that. But as far as this material is concerned, and carbon fibre weave, I am going to be looking at adding functional groups to the carbon fibre weave. Nitrogen with urea, which was that video of Robert's that I talked about, that I keep going back to, the carbon cloth supercapacitor one, or carbon cloth capacitor, whichever. I seem to think that if I could get some active material into this felt, better things might happen. Who knows? Let me know what you think. Get some of it, try it. Now, as I said, I saw a UK company selling this stuff, and they sell all sorts of graphitic materials, mainly for ovens and stuff like that, high temperature ovens. But they also sell this, and they sell graph oil as well, this particular UK company. If I can find it on the computer, I'll put a link at the end of this video. But of course I just left it, and I thought, yeah, I'll ring them one day and try and get a sample or whatever. And then someone on YouTube used this and said, oh yeah, you get it on eBay. So obviously, again, it's Chinese. You know, we don't know what the specifications are, and you never will. You never know that, because I checked to see what this Chinese company on eBay also sold, and it's, you know, high-heeled shoes and handbags and, you know, balloons and, you know, all that sort of stuff as per usual. So you're never going to get anywhere with asking what this is. The problem with it, let's get back to that. There's a piece of the same material here, and there it is. It's dry. There's nothing, you know, it's the same as that. It's exactly the same material. Okay, exactly the same. In fact, it was cut off of this, obviously, there, or somewhere there, I don't know. I cut this off, and that was the piece that I intended to try. So where's the problem then? Well, on its own, it sat there, or on the shelf. I intended to try it, but look at this. And this bit, I don't understand. If I put my probes back into that material and show you what that says. 1.3 ohms, fair enough, we know what that's like, we know what it does, we know what it says on the tin. Now I'm going to do the same with this material, the one that's been sat around. Now you can see the probes are right in there, okay? I'm hoping you can see that, because it says 185 ohms. What's going on there? Now, I can promise you I haven't tried it, tested it, used it, or anything. Now that other one was rolled up, wasn't it? So what I'm going to do is roll this one up as tightly as I can. Like that. Now I can't roll that any tighter. And I'm going to put one probe in there and one probe in there. .45 ohms. What's that all about? I'm going to push on the probes now, as hard as I can, without breaking them, obviously. 36 ohms. I don't understand it. I just don't. Now the piece that's on there, on this battery, this paper battery, I've tried the probes in it and it was, I don't know, 1.4 ohms, same as, I'll try it again. It's dry on the piece that I'm testing. Yeah, 1.4 ohms. So you tell me, I don't know. I just do not understand that bit. Well, I don't know what to say, because I just do not understand it, and that's all there is to it. It's just a piece I cut off and I left it on the shelf. That's it. So where do I go from here then? I don't know. More testing with this material, obviously. That on the data curve, that hump that we get, I get it every time, right down like that. Even on this run, this 300 milliamp run, yeah, got the same one. We ran at 5 minutes, you know. I don't know, but anyway, onwards and upwards. I've got lots of experiments to do. You know, I've still got stuff to do. I'm still playing with certain things, and obviously I get sidetracked into other things like exclusion zones, which I need to sort of understand now for my own purposes, not because of, you know, what Pollock's doing or anything like that. More really what Ray's trying to achieve. So have a look, guys. Give it a chance. You know, you might look at this from the beginning and think, you know, what's this all about? But if you watch the videos in succession from the start to where he is now, you'll get a feel for what's going on, because the word bio means everything on this particular site. So it is worth looking at if you're interested, of course. If you're not, then don't even bother, you know. If you look at the first 3 and think to yourself, no, I'm not interested in the rest, just don't watch the rest, and that's all there is to it, isn't it? But a very interesting guy. Does a lot of research, biological research as well. So that's a big up for Ray. I hope, Ray, that you get more subscribers and more views in the next few weeks. That'd be fantastic, and then other people can continue your work alongside you the way I am. So that's that. Now, this material on the cathode, the active material, like I've said many times, it's a 3-part blend, and I've never said what the 3rd part is. Really, not because I didn't want to say, but because I wanted to further my tests to make sure that I still want to use or maintain and keep this 3rd component, with the initial component being manganese dioxide with garlic carbon, which I put in any material that I put on the cathode now for the functional groups. I've got to find a way of doing that myself, and I am trialling that with sulphur. And the 3rd component, well, do you know what? I'm going to tell you. It's a material that I looked at about 6 months ago now. And one of my subscribers, a guy called Peter Middleton, he knows his onions. He knows a lot. He's tried a lot, tested a lot, and he knows a lot. And from time to time he says, Kev, why don't you try this? Kev, why don't you try that? Kev, have you seen this paper? But he also explains stuff as well. He doesn't just talk about it. Peter actually explains stuff. And if you want to look at some of his comments on my fairly recent videos, you can. it's all worth looking at. Now, Peter said to me, I think it's about, I don't know, 6 weeks back, he said, "Oh Kev, have you seen this stuff? Have you tried this stuff?" Well, lo and behold, I was looking at it 6 months back, and then I just completely forgot to buy some. Because when your head's all over the place, that's what you do, you forget things. So I thought, yeah, okay, I'm going to get some of that because it looks interesting. And I'll show you what it is, if I can. Yeah, I think I can reach. Now, I'm not going to put a description in the link or anything like that. You can see the company name, you can see exactly what it is on the tin, or the tub. Okay, now what it is, it's from a company called Easy Composites, and it's milled carbon fibre. Okay, so this is a 2 kilogram tub, which costs like 60 quid UK money, £60. I would imagine that's what, I don't know, about $80 or something like that. So yeah, you can buy smaller quantities, but I don't ever do that. Whatever I'm doing, the minimum I buy of anything is a kilo, and that's all there is to it. So, milled carbon fibre. Now, is there a part number there? No. No, 100 micrometers according to that. Fibrous powder, manufactured from recycled carbon fibre. Use of milled carbon fibre, there's a range of applications. Well, whatever, you know. That's the third component. Now, on its own, this stuff is good. It works as an active material. There's a good tip. So, I'll put that there. Oh yeah. Now I've just got it in a tub there, and I'll just call it mill, so I know what it is. Because on its own, you could mistake this stuff for a lot of things, you know. What I'm going to try and do is show you this stuff, if I can find a piece of paper. I'll put some of this stuff on the paper. Now, as I'm doing that, there's a dust coming off that, so you can see just how fine it is. And you can sieve this stuff. Okay, you can actually sieve it. Now, I'm doing this so you can see that on that paper there, you can see the dust trail where it slid down the paper. So you can see how finely it's milled. Okay, look at that. Now, like I say, you can use this stuff on its own as an active material, but, and there's always a but, isn't there, it gives really strange readings on the data logger. It's sort of, the voltage drops like that, and then it comes right back up to where you wouldn't even expect it to, and then goes like that, and then you get the tail off at the end. So that's that. I've got a feeling this stuff would work extremely well in supercapacitors. I don't know why, and I don't intend to try it, because I don't want to build a capacitor yet. I do want to build a capacitor. I do want to build a supercapacitor for reasons of my own, to couple up with a battery at a later date, and I'll tell you more about that as and when. Milled carbon fibre. Get some, have a go. You won't waste your money on that one. So, the three components then. The reason I was reluctant to mention the milled carbon fibre in other videos is the fact that I wasn't certain that I was going to continue with it, but as the more I've had a play, and the more I trial various blends, you know, 0.1 of a gram of that, 0.2 of a gram of this, and whatever, it's coming to its own. And it's not a magical potion. What it is, it's part of the system. It's become part of that system. So it's giving results. Well, you've seen the results because it's on that battery, that paper battery. Those three components that I've mentioned are on that small paper battery. I'm looking for that piece of paper again. Because that's it. That's how big that paper battery is. I know I keep saying it, but I'm just, that's it. Right? I'm astonished at, you know, the power that that thing's given. I know it's not, you know, a lot, but if I made that now a lot bigger, which I am going to do, because the drawback before with making a complete paper battery, which is why I had to, earlier on I had to use aluminium, which I don't want to use, because there's lots of ugly reasons why we can't, shouldn't, wouldn't, and all the rest of it. You know, it's not the way to go, especially if you're using salts. Now, the drawback was a piece of carbon big enough for my anode. Well, I haven't got that problem now, have I? Because I can use a piece of carbon fibre weave as big as I want, right? And paint my graphite on it, like I've explained. That's exactly what I've done in this one. And go again with a big paper battery. And I'm talking like not 4 times that size. I'm probably talking maybe 10, I don't know. I'll have a look at it and we'll see. Now this testing that I said I'm going to be doing with the 3 batteries, the small carbon one with the that small graphite plate, and this larger paper battery, and then I was describing the larger battery with 2 of those carbon plates together. And what it is, they are actually wired together. I haven't just touched them together. I've actually drilled and riveted a cable from one to the other, so that's how they work. The drawback in building a bigger one was those carbon plates. You know, I ain't going to buy any more because they're too expensive. Even from China, just one was like £9 something. Yeah, right. So now, as you know, I've done the carbon fibre weave, painted graphite on it. And I think I used the 35 micron one for that. I've got a feeling that what I should be doing, again to test this further and see if we can better it, is I don't know whether I should be putting, I've got some 4 micron flake graphite, and I've got 35 micron flake graphite. Is it 35? I don't know, the tub's up there somewhere. 35 or 45. So that's that. You know, further testing to be done there. Now this felt material, as I've said, I will be testing this again. I will be trialling that again on the cathode, not the anode. But I will be trying to impregnate this with my active material. How successful that's going to be, I don't know. I've got a feeling it might involve the my vacuum pump, but we'll see. As I do things, I'll let you know, as always. So I'm sorry if early on, you know, a lot of people thought, oh yeah, this guy's hiding stuff, he's not telling us the whole story. But I have explained time and time again why I do that. You know, I'll go, well, yes, I'm using X component on this, I'm trialling it. You know, if it's rubbish, why bother telling people? You know, if you get to the end of it and you get a good result, then it's worth talking about. So that's that. Anyways, I'm going to leave it at that because I've been doing that for long enough again. Catch you in a bit.
Do you know what? Me being me, I just couldn't resist doing this one. This will be the last test. I'm not going to go any higher than this just yet until I've had a play with these new materials. But hopefully you can see where that red line is, and hopefully you can see that top right hand corner, and it says 500 milliamps. And again, I'll show you. It's not going to last very long, but it's that paper battery again. With that new material on that I've shown you, described on the cathode, at carbon felt, and my new anode, which is carbon fibre weave with painted on graphite, with the active materials, anode and cathode, as I keep describing, or I've just described the cathode now, so you know what that is as well. So this is 500 milliamps then, half an amp on that little paper battery. Now, I haven't freshened it up throughout, you know, rebuilding it again or anything like that. I haven't put any more electrolyte on it. It's just these tests of what you're seeing from what I've said, and that's it. So that's 1 minute 20 so far at 500 milliamps. And I'm going to do it again because that's the size of the active surface area. I love it. And we got that strange movement again there, look. Exactly the same. Now this is going to stop at 0.4, we know that. We might even get a glitch at 0.5, we know that. So we'll just let it run through. And we're at 2 minutes, look, 500 milliamps. Wow. I love that. Oh, and the electrolyte is just choline chloride, urea as a deep detective solvent, 25% water, DI water, aqueous. And look at that go. I can't wait to build a big one of these. I'll tell you now, I just can't. I'm going to do that this evening. You may get to see this video first, but I'm still going to do that this evening. Dare I say we're going to reach 3 minutes on this. And that's, according to that, it's going to, well, oh, the glitch, right, okay, that's what I was looking at. Alright, so that's 407 milliamp, back to 500, look, it got confused again. Heaven knows why. I don't know what that is, I really don't. But what I'm going to do is set another test with a cut-off voltage at 0.55 volts. So we're above that 0.5, and let's see what happens. Three and a half minutes, 500 milliamps. Wow. Constant current. Four minutes. Well, I knew we were going to get a good recovery, because you always do when you run the higher current tests. I mean, we've only got 25 milliwatt hours there, but significantly the capacity is 34 milliamp hours, which is above the energy rating, which is pretty good. Now, what I'm going to do while this is still running is I'm going to go and set that to 50 milliamps, look, and I'm not going to wait for a full recovery. I know that's going to get to 2 volts, no problem whatsoever, but first we'll clear that curve like so. Okay, we're at 1.8 and I'm going to press start. And look at that flat line. Wow. Now unfortunately I've got to be quick because I've just realised I've got an appointment with my GP, and I still haven't done that little bonus bit at the end yet for the end of this video, which I'm going to do it any time soon. But the problem is I need this camera. So that looks like it's going to run on for quite some time. Look how flat that line is. I've got a feeling that, this new material's got some legs. I still don't understand that one piece I cut off, and it's like, you know, 50 ohms, but maybe I should just cut another piece off and leave it sat around and see what happens to it. Really strange, that. Really strange. Okay, I'm going to pause the video because I don't know how much memory I've got left. Not a lot, the way I've been talking. I'll just let that run through and come back. Well, I've got to admit that's quite impressive. 35-minute run there, look. With that 50 milliamp load. There's been some recovery, whether that's, oh, well, I was going to say going up or down, I don't know, it's still going up according to that. A better curve, I'm glad to say. So that's going to be it for this video. I'm going to continue with this material now and try some other stuff with it. Bit of functionalisation, whatever. I'm going to try incorporating some of the active material within that material. As it's a felt, how successful that's going to be, I don't know, but I've got a trick up my sleeve with that one. So we'll have to see how that one goes, I think. But the second I know more, so will you. Over and out.